Welcome to the lecture series of characterization of materials. So today is the last lecture regarding scanning electron microscopy, and the topic of interest is electron matter interaction. Just to review the previous lecture, so here's the SEM layout. The electron gun emits electron deflected by the condenser lens, deflection coils, final lens, and then each beam pass by the specimen, and the electrons are then detected by the electron detector. Then these electrons are amplified, and then you can see an image on your screen. So the same thing is mentioned here in the bullet points. So SEM use a beam of high energy electrons generated by electron gun, processed by magnetic lens, and then focus on the surface of specimen, systematically scan across the specimen. So the specimen is scanned by line, start from here, here, and then you can see on your screen that image is forming from top to bottom. So it's basic from the previous lecture. So basic terminology is about the SEMs are the magnification. So magnification, if you refer to dictionary, then it shows the enlargement of anything. So in case of SEM, it's an enlargement of image or portion of image. For example, as you can see at top right hand side, there are two images are taken at low magnification and high magnification, and these are the line scan, like beam of electron passes by from top to bottom. So you can see the area that is scanned is very much high in case of low magnification, whereas in higher magnification every small area is scanned thoroughly. The same is translated in the bottom right images. If you move from left to right, then you can see that this image shows like there are some artifacts on the surface in a circular form. So if you want to view a higher magnification, what you will go, you will move from here to here, means a very small portion has to be scanned by the beam of electrons. If you want to scan this artifact, this circular artifact, so what will happen, the electron beam has to be passed by this small area so that to scan the image. So what you will get, this. So this portion is from this image, it's only small part. And furthermore, if you want to further clarify what's inside this artifact, how it look like, how its surface look like, because from left to right there is more clarification of the surface morphology. So what you will see, you will pass the line scan more thoroughly on very small area. So you pass line scan more thoroughly on a very small area. So what you will get at the end, this image. So basically this image is from this small portion of the very first image taken by scanning electron microscopy. So what is happening in the magnification, your beam is focused on a very small area just to view what's look on the surface. The next and very important terminology that we are going to discuss here is the spot size. So what is happening in the spot size? By means of spot size, we actually resolve the fine structures over the surface of specimen, or we are resolving the surface morphology of any subject. Basically, the surface you are viewing on the scanning electron microscopy, it has contours up and down, up and down. So the variation in this up and down on the surface or the surface morphology, it can be easily resolve by varying the spot size. So what is happening that in case of large spot size, the prop size is a bigger one. So if the spot size is large, the prop size is bigger one, and then beam is passing by like line by line scaling over the surface, line by line scaling over the surface. And then if the spot size is large, then a very less time is spent over the surface. By this means the corners or the fine structures are passed by, means the fine structures in case of large spot size cannot be differentiated. So as you can see, in case of large spot size, the curvature, the sharp curvatures, they are missed. Just you are seeing the surface morphology on a rough scale. So if you want to improve your image, or you want to see more in-depth detail, then you have to increase the spot size, or you have to small the spot size. So in case of smaller spot size, what is actually happen that more time is spent over the line scale. This means the prop size is less and more time is spent over the entire line scale. So in this case, the contours or sharp surfaces can be easily scanned, because more time is spent with the smaller beam with the high intensity electrons. So by line scanning, you can easily view a very fine structures on the surface. So the relative term large spot size and small spot size, they are very much important, and by decreasing the spot size, what you are doing, you are resolving the image to very fine scale. So if you want to have a quick look on the surface, then normally you use large spot size, because in this case the line scans happen very quickly and less time is spent over the surface. But if you want to analyze the surface in more details, then it's usually preferred to use small spot size. By this means more time is spent over the surface, and the sharp curvatures or the surface morphology, which are very complex, can be detail scanned. Let's discuss what will happen if an electron beam emitted by the electron gun hits the sample. Definitely these electrons will interact with the atoms on the surface of the sample. In the previous lecture, I told you that in case of electron microscopy, we are dealing with the surface morphology. It means we are viewing only surface of the sample, not the bulk material. What is inside the material, it's very difficult to be detected by scanning electron microscopy. By means of scanning electron microscopy, you can only observe the surface of any sample. So what is happening if a high energy beam of electron, after passing by a series of magnetic coils that focus on a very teeny small area of the sample, on the surface of the sample, so if these electrons are bombarded over the very small surface area of the sample, then what will happen? First thing, maybe some of the electrons will be deflected back. So electrons, the high energy electrons, they are bombarded on the surface of the sample, some of the electron will be deflected back. So these deflected back electrons are termed as backscattered electrons. The second chance is if this high energy beam electron hit a very teeny small surface area of a specimen, then the chances are this high energy electron transfer some of the energy to the atoms located on the surface of the specimen. As atoms are comprised of electrons and the nucleus, so what is happening that in the outermost shell of electrons, the chances are they will be knocked out of the atoms. If these electrons are knocked out, then they go out of the specimen and they are referred to as secondary electrons. So these secondary electrons are totally different from the backscattered electrons. I will repeat it again. The backscattered electrons are the electrons which are very much similar to the beam of electron, which is hit on the surface of the surface of the sample, and they are deflected back. Whereas the secondary electron, these are the electrons of the atom of this sample of the surface of the sample. So the secondary electrons are from the atom of the surface of the sample, because these electrons, the high energy electron, when they hit the surface of the sample, then they impart some of the energy to the atoms of the surface of the sample. Then these atoms, in these atoms, the electrons, they are knocked out of the atom and they are gone outside. If they go outside, they are detected as a secondary electrons. A very important thing that I have to mention here is these secondary electron and backscattered electron, they are totally different, and the detector who detect backscattered electrons are totally different from the secondary electrons. This means there will be two detectors. One will detect backscattered electrons and the second detector will detect secondary electrons. So the energy level of backscattered electron will be totally different from the secondary electron. That's why the detection level of both the detectors, detector who detect backscattered electrons or detector who detect the secondary electron, will be totally different. Definitely the image formation of backscattered electron will be totally different from the secondary electron. For most of the time, the image formation that we are observing in the literature is from the secondary electrons. Or I have to say that most of the images that you are observing in the literature are from the secondary electron. So these secondary electrons are very much important for the scanning electron microscopy, and the image formation you are observing are most of the time from the secondary electrons. The other thing that is happening here, if there is a bombardment of electron over surface of atom, then there will be transformation of energy in the form of heat energy. So if two bodies are collide, then the chances are by this collision heat energy will produce. And also by this collision, as I mentioned, that the outermost shell electrons of the atom of the sample, they are knocked out. So if they are knocked out, then the electrons will jump from shell levels. So if the electron are jump from the shell levels, then they emit X-rays. So you will get the X-rays as well. So by these X-rays you can detect the composition analysis of the surface of the specimen. So it's very, also the X-rays are also very important. The other two elements that most of the time scanning electron microscopy, people who are discussing the or who are studying the scanning electron microscopy, they are normally interact with the cathodoluminance and the Auger electron. But the most important concept here is in case of electron matter interaction is either backscattered electron and the secondary electrons. So the image formation is either from the backscattered electron or secondary electron, and most probably the image formation that you are viewing is from the secondary electron. And sometimes you are also interested on the composition analysis of the surface, so in that case X-rays are equally important. But the cathode luminance and eager electrons, they are used by some researcher for very specific studies.